Hello. I hope you're on page 140 in your workbook because that's what we're going to work on. So I just wanted to talk about Pythagorean theorem. Again, if you've been here for memory work, you know that the Pythagorean theorem says that in a right triangle, the sum of the squares of the legs are equal to the square of the hypotenuse. So we call those two legs A and B, and so that would say A squared plus B squared is equal to C squared. All right, the sum, addition of the squares, right, we're squaring them, of the legs in a right triangle equal the square of the hypotenuse. Right, we only ever say legs and hypotenuse in a triangle that's right. Right, and again, that means it has an angle that's 90 degrees. It looks like a perfect L. Usually we mark that with a little square in there to just make it obvious that it's a right triangle. Again, that was difficult for me to do in these problems without a lot of extra work, so I didn't put it in there, but we're going to assume for all of these that they are right triangles. All right, and again, if we think about that visually, hold on, let me flip over to the back here just so I can sketch this, that if I have a right triangle, all right, and I draw a square along each leg. So this is a leg and this is the leg. The two sides that make that right angle are called the legs. And then the hypotenuse is the longest side. It's the slanted one. Right, so we would say the sum of the squares of the legs in the right triangle equal the square of the hypotenuse. So visually what that means is if I were to make a square on each side right here, it's not a very good square, but just deal with that. All right, if I were to make a square right here, and this side, let's say we're A, then the area of this square is A squared, because it would just be length times width. If I were to make a square on this side, again, if this is B, then the square would look like this, and the area of it would be B squared. And if I were to do the same thing on the hypotenuse, and again, that's C, then the area of this would be C squared. And it's saying that the area of the squares that are formed along the two legs has the same area, the sum of these two legs, the sum of the areas, sorry, that's really coming out poorly. The sum of the areas of these two squares is equal to the area of this big square. Right, so from a geometric perspective, that's what's going on. But we just say it as A squared plus B squared equals C squared. Right, you might wonder, can I mix the letters up? And the answer is no. You could write B squared plus A squared equals C squared. That would be fine because addition is commutative. But it wouldn't make sense for you to switch C to the other side. It doesn't make sense then to have a smaller, like if we try to do A squared plus C squared equals B squared, that doesn't make sense. This is this medium-sized square plus the large square equals the little square. That doesn't make sense. We always have to do small plus medium equals the large. So it always has to be the A squared plus B squared equals C squared, or the reverse where we did B squared plus A squared equals C squared. So either one of these is fine, but don't put C as part of the sum there. That is wrong. And you will get some weird answers. All right, so let's do a couple of these. So in many of the first ones, oh no, that's not true. We've got a couple here where the hypotenuse is the thing that's missing, and then we've got a couple here, so like 3 and 7 and 8 and 9, where one of the legs is missing. So I just want to do a couple with you because then you're going to do the rest on your own. So let's say, let's do 1 and 3 and 7. All right, so 1, 3, and 7. And then you'll get to do these on your own. Okay, so again, I'm going to put that little square in there to verify that this is a right triangle. And again, I should have put them in there, but it was going to take a lot of work. So, all right, so it's saying A squared plus B squared equals C squared. Now you might say, Ms. Taylor, does it matter whether I pick this to be A and this to be B? And the answer is no, it really doesn't matter. So you do whichever one you want. So I'm going to pick A to be 6. So it's saying 6 squared plus 3 squared is equal to C squared. All right, 6 squared is 36, and 3 squared is 9. That equals C squared. And then 36 plus 9 is 45, equals C squared. All right, now we've already talked about this. If I have c squared equals 45, then in order to figure out what c is, I have to undo the squaring, and that is done with a square root. So I'm going to take square root of both sides. And so I would get c equals, and again, normally we say plus or minus the square root of 45, but in this case it doesn't make sense to say, oh, the hypotenuse could measure negative square root of 45 centimeters. That doesn't make sense. So in the context of finding the side length of a triangle, we would say, no, we're not going to use the minus one. We're just going to choose the plus one, or the positive one. All right, and then again, we could simplify this because there is a perfect square inside 45. Right, again, what we talked about the other day was we could break this down into two parts. Now, there are many things that multiply together to give you 45, but the one that we want to choose is the one that involves the 9 in it, because 9 is a perfect square. So we're going to say this is the square root of 9 times 5. And then we also said, well, square root of 9, actually, let me just break it apart. Square root of 9 times square root of 5. You can just go right from this step to this step, but I just did that for fun. All right, then we can say, oh, I know what the square root of 9 is. It's 3. So then we would end up as our final answer as 3 times the square root of 5 centimeters. Now, if you wanted to get out your calculator and estimate that, you could just by doing 3 and then hitting the square root button and then 5. We'll do that for another one, but for right now, we'll just leave that one there. Okay. All right, for number 3, notice that we know the hypotenuse, because again, that's the slanted one. It's also the longest one. We're going to do a squared plus b squared equals c squared. Right, again, you pick whichever one you want for, oh no, I can't pick whichever one I want for a because I'm told I'm missing a, so we're going to leave that in there. And then b is 8, so we'll say 8 squared equals c squared is 30 squared. So again, don't make the mistake of putting 30 in here and then the 8 in here. The 30 is the hypotenuse. It must play the role of c. All right, so then we have a squared plus 64 equals 30 squared is 900. I'm going to subtract 64 from both sides, so I end up with, oops. We subtract 64 from 900 and we end up with 836, right? 64, yeah, 836. All right, again, we're going to take the square root of that. And so we get, all right, the square root of a squared is just a. Again, that square root undoes the squaring, so it just gives us a back. And then we have square root of 836. Again, notice I'm not doing plus or minus on here because it is a length and we can only have positive lengths. Okay, so we need to find out what goes into 836. Using our divisibility rules, I can see that 4 goes into that. All right, because again, the divisibility rule, or one of the divisibility rules for 4 is that the last 2 digits are divisible by 4, and 36 is. So let's just take that out. So we end up with a equals square root of 4. And then the remaining thing is 209. 209, I believe, I don't know that it's a prime, but I don't think any perfect squares go into it. I would check to see, well, 2 doesn't go into it, 3 doesn't go into it because the sum of the digits is 11. Since 2 doesn't go into it, no even numbers go into it. 5 doesn't go into it. 7, no, I don't think so. I think that's not going to simplify anymore. So we end up with a equals 2 times the square root of 209. Now, I am going to check on this one because I want you to make sure that the value that you get here is less than the length of the hypotenuse. If it's bigger than the length of the hypotenuse, we have a problem. So let's just check that. So let me show you how to do that. Sorry, I should have had my calculator on the ready here. So let's turn it on. Again, I think this is probably the kind most of you have. All right, so I'm going to do 2 times, and then the square root button is right over here over the x squared, and the way we get to it is we hit the second button, and then we hit that, and it'll open a square root with a parentheses in it, so we type in 209 and close the parentheses. All right, and we find out that the approximate value of that is 28.9, and that is less than the hypotenuse. Again, if we had gotten something that was equal to or bigger than the hypotenuse, we would know that we made a mistake. But I feel confident with this, that is the answer right there. Okay, let's do one where we have to figure out what b is. All right, again, once we've done these two, it really doesn't make a difference. But let's just go ahead and do that just for practice. So again, a squared plus b squared equals c squared. And again, we're going to put in the sign for the right triangle. So I know that a is 5 because I know that b is what we're looking for. So 5 squared plus b squared equals 7 squared. Again, always put the hypotenuse in for c. We've got 25 plus b squared equals 49. I'm going to subtract 25 from both sides, so I get b squared equals 49 minus 25 is going to give us 24. I take the square root of both sides, again because square root undoes squaring, so we end up with b equals square root of 24. All right, again I need to break this down into two things, one of which is a perfect square, so I'm going to go with 4 and 6. Square root of 4 is 2, and square root of 6 is nothing that we're interested in. And so we would say that is our answer. Again, you could find a decimal approximation, but in most of these we just leave the answers in, we call this reduced radical form. Again, that's what the directions say up here. Leave your answer in reduced radical form. In other words, don't change it into a decimal. You can do that just to make sure that you have not messed up and gotten an answer that's bigger than your hypotenuse. In fact, let's do that again for this. So we would do 2 times the square root of 6, and just confirm it's not bigger than 7. All right, so it's not. We get just about 4.9. Okay, so you're going to try the rest of these on your own, and then we'll look at page 140 in just a second. Okay, I want to look at one problem on page 141 and one on page 142, just so that you can do some more. All right, it says show a work on a separate piece of paper. I don't think we'll need a separate piece of paper. All right, so the difference between the problems here on page 141 and the ones on page 140 is that we don't get a picture. All right, so either you could draw the picture. All right, so I'm going to draw something like this. All right. This is going to be my right angle, and so A and B are the legs, and C is the hypotenuse, and so I'm going to put this as A and this as B, and then I don't know what C is. You could also just skip that step and do a squared plus b squared equals c squared and fill in A, B, and C without doing a picture at all. Right, so if I put in A, that's 3 squared plus 4 squared equals c squared. All right, 3 squared is 9, 4 squared is 16, equals c squared. And then 9 plus 16 is 25. Wow, this is a special one. All right, when we take the square root of both sides, and the square root of a square, that square root undoes the squaring. So here we end up with just plain old c, and the square root of 25 is 5. All right, so then that means that this triangle, interestingly, has all whole number sides. All right, 3, 4, 5. This is a special triangle because of that. It's called a Pythagorean triple. All right, because all sides are integers. Again, the ones that we did on the previous page, we ended up with the square roots as sides. And so when we find one that has integer sides, you would just say it's a Pythagorean triple. This is not the only one. You'd be surprised that there are quite a few more, and you'll end up talking about them a lot in geometry. All right, so again, this page is very much like the last one, except you don't have the diagram. You don't need to make a diagram, although you're welcome to, but you just want to plug the values in. And again, sometimes, no, every single time we're looking for C on this page. All right, and then page 141, these are all word problems. When would you use Pythagorean theorem in real life? Plenty of times. All right, so if you have anything that looks like a right triangle and you're trying to find side lengths, that's when you would use Pythagorean theorem. So here we have a ladder is leaning against the side of a 10-meter tall house. I probably should say 10-meter tall house. If the base of the ladder is 3 meters away from the house, how tall is the ladder? All right, draw a diagram and show your work. Okay, so we've got a house that's 10 meters tall, and that ladder is leaning against that. All right, so we've got the roof up here and everything, but the ladder is right here and it's leaning against that. We know that the house is 10 meters right here. So the height of the house is 10 meters. And it tells us that the base of the ladder, all right, this is the base of it where it's touching the ground, is 3 meters away from the house. And it says how tall is the ladder, meaning how long is it right here? That's what we're being asked to find. So draw a diagram, which we just have here. Again, I'm going to put the right angle in here. We assume that a house is perfectly perpendicular to the ground, otherwise we end up with some structural issues. So we're going to put that little right angle in there to show that this is a right triangle, and then we're going to figure this out. All right, so again, we're not told A, B, and C this time, so we're just going to have to figure that out. Again, A and B are the legs, and C is the hypotenuse, the longest side of the right triangle. So we're going to say A squared plus B squared equals C squared, and then we'll do 10 squared plus 3 squared equals C squared. 10 squared is 100, 3 squared is 9, and that equals C squared. And then we get 109 equals C squared. All right, take the square root of both sides. Again, the square root undoes the squaring, so this ends up being just C equals square root of 109. All right, if we try and find factors that go into 109, I do not believe there are any. 2 doesn't go in, 3 doesn't go in because the sum of the digits is 10. No even number is going to go in. 7, well, 5 obviously doesn't, 7 doesn't, and 9 doesn't. 10 doesn't because it's even, but the closest perfect square to that is 100, and so if 10 doesn't go in, then nothing's going to go into it. Or if anything up to 10 doesn't go into it, nothing's going to go into it. So we could just stop there and say C equals square root of 109, but that would be kind of weird if you went into like Home Depot or something and said, I need a ladder that is square root of 109 meters. So in word problems, we tend to not leave it in reduced radical form. We tend to give the exact answer. All right, so I'm going to say here that I want to do square root of 109. So it's almost 10.5 feet, so, or I'm sorry, meters. So this is approximately 10.4 meters, so almost 10.5 meters. All right, so if you had a house that was 10 meters tall and you wanted to make sure you had a ladder that went all the way to the top, with it being 3 meters away from the base of the house, you would have to make sure that it was 10.4, 10.5, 11 meters, something like that. Okay, and again, because this has units with it, you would have to make sure that you write the units. On page 141, there were no units, and on page 140, there were units. I didn't mention that, but always make sure that if they give you units, that you write the units. Okay, that's it. Bye.